Now we'll talk about properties of special parallelograms in the form of theorems. The first theorem is theorem 7.11, the rhombus diagonals theorem. So you have a parallelogram. A parallelogram is a rhombus if and only if its diagonals are perpendicular. So if I have the parallelogram ABCD, the diagonals in this case BD and AC, if they're perpendicular, then that parallelogram is a rhombus, which would imply all the sides are congruent. It's one of the properties of the special parallelograms. Again, since a rhombus is a parallelogram, it would still possess all the properties that a parallelogram has as well. And then theorem 7.12, the rhombus opposite angles theorem. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So what that means is if I have a parallelogram, again, I'll call it ABCD, if each diagonal bisects a pair of opposite angles, for example, if diagonal BD bisects angle D and angle B, not only would it bisect each of those opposite angles, but each of these parts would all be congruent. Because it's a parallelogram, opposite angles would be congruent, but then diagonal AC would need to bisect angles A and C as well. It would look like this again. These four angles would all be congruent, but not necessarily congruent with these four angles. But if the two diagonals bisect a pair of opposite angles, then the quadrilateral, the parallelogram, I should say, is a rhombus. And then the last theorem is theorem 7.13, the rectangle diagonals theorem. So a parallelogram is a rectangle if and only if its diagonals are congruent. So I have a parallelogram ABCD. If the diagonals are congruent, BD and AC. So if BD, that segment, is congruent to AC, then the quadrilateral or the parallelogram is a rectangle. Okay. So each of the properties are given in terms of biconditional statements. For example, going back to theorem 7.11, basically what that says is a rhombus has the diagonals that are perpendicular. Okay, theorem 7.12, opposite angles theorem. The diagonals of a rhombus bisect each of the opposite angles, and then the rectangles diagonal theorem basically just states that the diagonals of a rectangle are congruent. Notice there's no theorems about squares. A square is both a rectangle and a rhombus, so a square possesses not only all the properties of parallelograms, but a square possesses the properties of a rhombus and a rectangle as well. For example, even though it's not a theorem, as I mentioned, and I'm not going to write it down, a square has the diagonals that are perpendicular because a square is a rhombus. A square's diagonals bisect the opposite angles, and a square's diagonals are congruent since a square is a rectangle as well. So note that even though there's not really any theorems about squares, there kind of are because a square, again, is both a rhombus and a rectangle. But those are all the properties of the special parallelograms. Rhombi, that's plural of rhombus, rectangles, and squares.